Welcome to Siwale Production. Today we're looking at simple interest. Simple interest is defined as the fixed percentage of principal that is paid to an investor irrespective to the number of years the principal has been left on deposit. That means that money that is invested at simple interest will increase in value by the same amount. And let us look at this example. For example, if Mr. A invests in project X 500 kwacha and is told that he will be receiving an interest rate of 10%, that means that Mr. A will be receiving 50 kwacha of simple interest each and every year. Let us now look at the formula for simple interest. So the formula for simple interest there, we have I is equal to P multiplied by rate multiplied by the T there. So where I is equal to simple interest, then where P is equal to the principal, then R is equal to the rate of interest, then where T there is the number of years. So this is the formula that we use when calculating simple interest. So it's I is equal to P multiplied by R multiplied by T there. And we gave our first example, and in our first example we gave if Mr. A invest a 50 if Mr. A invest a 500 kwacha in project X, and we were told that Mr. A will be receiving an interest rate of 10%. That's the interest rate. So to calculate our simple interest in the first year there, so we can say I is equal to P multiplied by the rate there multiplied by the T there. So simple interest is equal to P there, that's the principal, and the principal there it's 500 multiplied by the rate there is 10%, so that's 0.1 multiplied by the T there, we are just calculating simple interest in the first year, so here we can say 1 there. So simple interest is equals to 500 multiplied by 0.1 multiplied by 1, we're going to have 50 kwacha. So that's going to be the simple interest in the first year. Let us look at the total value of the investment after T years. So to calculate the total value of the investment after T years, so what do I mean? So to calculate the total value of the investment after T years, we need to add the principal plus the simple interest. Let us look at this same example for Mr. A. So if you have been told that, can you calculate the total value of the investment after the first year for Mr. A? So what we're going to do here, we're going to calculate the simple interest in our first year, and we have already calculated that's 50 kwacha, and we're going to add this 50 kwacha to the initial investment, which is 500 kwacha. So to calculate the total value of the investment there for Mr. A, we are going to say our initial investment that Mr. A made, which is 500 kwacha, plus the interest for the first year, which is 50 kwacha. So the total value of this investment is going to be 550. So to put this in the formula, we need to know that the total value of the investment, which is represented by PT, is equal to the principal plus the simple interest. And our simple interest, we know that that's the principal multiplied by the rate of interest multiplied by the number of years. This is the formula that we use. So we can say our PT there is equal to, we can find the common variable there. The common variable there, it's P. So we're going to have P there, open bracket, P into P there, we're going to have 1 plus P into P multiplied by R multiplied by T there, which is the number of years. We're going to have RT. So the total value of the investment there, we can say that's P open bracket 1 plus RT. So that's the formula. So here we can say where our PT represents the total value of the investment or the future value. So this is the future value. Then where our P, we know that our P, we know that's principal. Then we also know that our R, that's the rate of interest. Then our T is the number of years. So let us look at another example. So in some second circumstances, you'll be given the future value, then you're also going to be given the rate of interest and the number of years. So in that instance, you'll be told to calculate the present value or the principal. So for us to calculate our present value there, we need to make the present value as the subject of the formula. So we know that our formula there is PT is equal to the principal open bracket 1 plus the rate of interest multiplied by the number of years. So PT is equal to P there 1 plus RT, that's the formula. So to make P the subject of formula there, we can say our principal is equal to our principal open bracket 1 plus RT is equal to the future value. So there we can say divide by 1 plus RT divide by 1 plus RT. So we can cancel out that. So we can say our principal there is equal to the future value divided by 1 plus the rate of interest multiplied by the number of years. So that's the formula that we use when we have been given the future value, the rate of interest in the number of years, and we have been told to calculate the present value. So let us look at now the examples. So we have our first example here. 2 million is invested for 4 years at an interest rate of 7%. Calculate the simple interest paid. So the first thing that we are supposed to do there is to collect our data. So what do we have? So here we have our principal. Our principal we have been given as 2 million. Then we also have the number of years. So the number of years, that's 4 years. We also have the rate of interest, which is 7%. And we have been told to calculate our simple interest. So we don't know our simple interest. So simple interest is equal to the principal multiplied by the rate of interest multiplied by the number of years, which is T. So our simple interest is equal to our principal there, that's 2 million, multiplied by our rate of interest, that's 7%. So that's going to be 0.07 multiplied by our T there, that's 4 years. So our simple interest is equal to 2 million multiplied by 0.07 multiplied by 4. We're going to have 560,000 as our simple interest. Let us now look at question B. Question B reads, calculate the total value of savings at the end of 1, 2, 3, and 4 years. Show that the total value of savings at the end of successive years is an arithmetic progression. So here we've been told to calculate the total value of savings at the end of the first year, second year, third year, and the fourth year. So we're going to start with the first year. So we know that the total value of the investment there is the future value is equal to the principal, open bracket, 1 plus RT. So there we can say the future value there, which is our P1, is equal to the principal. The principal there, we know that's 2 million, open bracket 1, plus there we know that our R there, that's 0.07 multiplied by our T there, that's in the first year. So PT is equal to 2 million, open bracket 1, plus 0.07 multiplied by 1 there. The answer that we're going to have is 0.07. So our PT is equal to 2 million, open bracket there. Then we're going to say 1 plus 0.07, we're going to have 1.07. So our PT there is equal to 2 million multiplied by 1.07. Our answer there is going to be 2,140,000. So that's going to be our future value there in the first year. So let us calculate in the second year. So in the second year, we're going to say PT is equals to principal, open bracket, 1 plus RT there. So we're calculating in the second year there is equal to the principal, that's 2 million. We're going to have 1 plus our rate, we know that's 0.07 multiplied by the term there, that's in the second year, so it's 2 years. So here our P2 is equal to 2 million, open bracket 1 plus, we're going to say 0.07 multiplied by 2, and that's going to give us 0.14. So our total value of the investment in the second year there, we're going to have 2 million. So we're going to say 1 plus 0.14, we're going to have 1.14. So there, the total value in our second year there, we're going to say 2 million multiplied by 1.14, and our answer there, we're going to have 2,280,000. Let us now calculate in our third year. So we're going to say our PT is equal to our principal, open bracket 1 plus RT. So our P3 is equal to our principal, that's 2 million, 1 plus 0.07 multiplied by 3. So our P3 is equal to 2 million, 1 plus, then we're going to say 0.07 multiplied by 3, we're going to have 0.21. So our P3 is equal to 2 million, Then we're going to have 1.21 there. So our P3 is equal to 2 million multiplied by 1.21. We're going to have 2,420,000. Let us calculate the total value of the investment in the 4th year. So we're going to do the same thing. The first thing is to write down the formula. So our P4 is equal to our principal, that's 2 million, 1 plus the rate there 0.07 multiplied by 4. So our P4 there, it's 2 million, open bracket, 1 plus 0.07 multiplied by 4. There we're going to have 0.28. So our P4 is equal to 2 million. Then we're going to say 1 plus 0.28. We're going to have 1.28. So our P4 there is going to be equal to 2 million multiplied by 1.28. We're going to have 2,560,000. So we have calculated the total value of the investment in our first year, second year, third year, and our 4th year. Let us look at the other part of the question. So the other part of the question reads, show that the total value of savings at the end of successive years is an arithmetic progression. So for us to know that the sequence that you are finding is an arithmetic progression, you need to find the common difference. And let us write down the sequence for these figures. So we know that in our first year we have 2,140,000. In our second year we have 2,280,000. In our third year we have 2,420,000, and in our 4th year we have 2,560,000. So we can write down that sequence. So that sequence, we know that in our first year we have 2,140,000, then followed by, in our second year we know that's 2,280,000. In our third year we have 2,420,000, and in our 4th year we have 2,560,000. So we have to show this sequence that it is an arithmetic progression, and I've said that arithmetic progression can be found when you are able to identify the common difference, and the common difference between the two numbers in the sequence has to be the same. And here we can say that we have our T1 there, we have our T2, and we have our T3, and we have our T4. So for us to calculate the common difference there, we can say our T2 minus our T1, or we can say our common difference is equal to our T3 minus our T2, or we can say our common difference is equal to our T4 minus our T3. And the numbers that we are supposed to find in all these circumstances has to be the same. So let us prove that. So we have our common difference there. We have our T2 minus our T1. Our T2 there, we know that's 2,280,000 minus our T1 there. Our T1 there is 2,140,000. So the common difference there we're going to have is 140,000 in our first instance. Let us look at in the second instance there. So our common difference is equals to our T3 minus our T2. Common difference there is equal to our T3. Our T3, we know that's 2,420,000. So 2,420,000 minus our T2. Our T2 is 2,280,000. So our 2,280,000. So a common difference there, we're going to have 140,000. Let us look at in the last instance. So in the last instance there, we have our T4 minus our T3. Our T4, we know that's 2,560,000 minus our T3. Our T3, that's 2,420,000. So we have our 2,420,000. And that's going to give us our 140,000. And as you can see, we have proved that this sequence is an arithmetic progression, and the reason is because it's giving a common difference in the sequence of 140,000. Let us look at question C. So question C reads, calculate the present value when the future value is 4 million after 2 years at an interest rate of 8%. So as you can see, in this instance, we've been given the future value. We have also been given the number of years. We have also been given the rate of interest. So it will be very easy for us to calculate the present value. And we know that the total value of the investment there, the formula that we use, we say our future value is equals to the principal or the present value, open bracket, 1 plus our rate of interest multiplied by the number of years. So here we know our PT is equals to P there, 1 plus RT. So to make the present value the subject of formula there, we can say our P, open bracket, 1 plus RT is equal to the future value. To make our present value the subject of the formula, we're going to divide by 1 plus RT on both sides of the equation. So we're going to say 1 plus RT there. So this is going to cancel out. So we can say our present value is equal to the future value there divided by 1 plus RT. So that's the formula that we are going to use. So here we can say the present value is equal to the future value divided by 1 plus RT. Our present value is equal to our future value. We know that's 4 million. So we have our 4 million there. Divide by 1 plus. Then we know that our R there, that's the rate of interest, which is 8%. And 8% there is 0.08 multiplied by our T there. Our T is 2 years. So we have our T2 there. So our present value is equal to, we have 4 million divided by, we have 1 plus, so we're going to say 0.08 multiplied by 2, we're going to have 0.16. So we're going to say our present value is equals to 4 million divided by, so we're going to say 1 plus 0.16, we're going to have 1.16. So the present value, we're going to say 4 million divided by 1.16. We're going to have 3,448,275.9. So that's going to be the present value of that investment. So that's how you can calculate simple interest. Just take note that simple interest, the fixed percentage of principal that is paid to an investor, irrespective to the number of years the money has been left on deposit. And we must take note that the money that is invested at simple interest will increase in value by the same amount. So those are the principles of simple interest. If you find these tutorial very interesting, make sure you share, like, and subscribe. I'll meet you in the next video. Peace and God bless you. If you want to get connected with me, you can actually check out my social media platforms. I'll meet you next time, and peace and God bless.